Welcome to Field Trials, a future farming webcast exploring innovations, issues, and perspectives in new farm technology. This is Matt, your Canadian farm kid and journalist host. Thanks for tuning in. Farmers have their pick when it comes to digital agronomy tools. They're pretty effective, there's lots of them, and they're getting better all the time. But perfection, of course, remains elusive. In this episode of Field Trials, we chat with precision ag expert and Kansas State professor Raj Khosla about how we can more effectively measure spatial differences in the field and make management calls without the guesswork. We also touch on what new measurement tools could look like, a brief history of GPS, and the relevance of doing more with less given our contemporary climate context and policy goals. I appreciate your time. You're a veteran in this space, the digital agriculture and precision agriculture space. I was reading through your bio. You've certainly got way more credential than me to be yapping about these things. So I guess maybe you can just give a little bit of a background for anyone listening on some of the key figures in what you've been done and what you've been up to, and then we can start talking about digital tools.
Right. So thank you, Matt, for extending this opportunity to speak with you. I've been involved in precision agriculture since the inception, from early to mid 90s. The change happened when global positioning systems was made available for civilian applications. This was 1983. And by early 2000, the encryption on the GPS signal was taken away as well. So what military had access to, all of a sudden civilians had access to that too. And that was a game changer, particularly for the proliferation of of precision agriculture, because now all of a sudden farmers could employ location-based agricultural practices. Why location-based agricultural practices? Because for decades, if not centuries, we have observed changes in our field and production and productivity as we go from one part of the field to another part of the field. And now, working closely with private partners, i.e. technology companies, they enabled the next generation of equipment that could apply variable rate inputs on the fly. And this was really a big change from traditional one-size-fits-all philosophy to where we can match inputs based on the productivity potential of soil and vary it so that we can minimize input application, or I would rather say optimize input application and maximize output.
Yeah, well, particularly this past year, certainly been a lot of discussion given the was it $1,400 a ton, or whatever the prices are for fertilizers alone, let alone other things.
Yeah.
So, talking about GPS, we went after it was kind of widely available to civilians from the United States military. We then, and correct me if I'm wrong, but initially it wasn't like we went from like a foot kind of difference variation to now we're at a point where it's very, very, very minute. So with that level, with like being able to get down to that scale, something that if I'm probably going to butcher what you said here, so I apologize for that, but something you've said before was digital tools, since we have this amount of accuracy, or we can achieve this amount of accuracy, we can get so much information that a lot of it you can't actually do much with, or it's like it's noise around. And so the phrase was rapid. We need to produce tools that provide rapid, reliable, and reproducible information. I mean, that makes sense, but that's got to be a bit of a tall order. Where are we at in terms of, there's a lot of software out there right now, and there's a lot of different growers using a huge variety of different agronomic tools. I mean, I'm assuming they don't all do that, and why not? I guess is
okay.
And this is coming from someone that's only himself really used some really basic stuff, and I have no programming background either, so I'm quite ignorant as to the ins and outs of these things.
I'll try to break it down and make it simple. So you're exactly right that once farmers started to use location-based agriculture or precision agriculture, what happened? They started collecting a lot of data, lots and lots and lots of data, and that's where we are. How do we translate data into information that allow us to make decisions in near real time. But let's take a step back. One thing we all should appreciate and realize is that we can only manage what we can measure. Okay, so think about it. We have sprayers, we have planters that can variably apply seeds into the ground or variably apply fertilizer, or that for that reason, a sprinkler irrigation system that can variably apply water or irrigation at the nozzle level. So if you're running a sprayer rig where the nozzles are 3 feet apart or less, and you're applying that at that granular level, you need information at the same granular level to be able to decide how much needs to be applied, where and when, right? And to enable that, we need to take measurements at spatial dependent densities. So let me elaborate on that. So if we were to take a measurement, let's say soil measurement at 1 point, okay, and we take another soil measurement, let's say 2 feet apart, what do you think is the chances that the two locations are related in space? Chances are high, right? But if we go 20 feet away or 200 feet away, as we increase the distance from one location to another, we're reducing the chances that the two locations and hence the properties of those locations are related in space, okay? And so that's called the spatial distance at which the relationship between 2 points break off. So for us to be able to derive scientific information, what's happening between the 2 points, we need to take measurements at a shorter distance where the 2 points are related in space. Am I making sense to you?
Yeah. So the idea that you're going to go take a piece of information from over there and then 50 feet that way, like that's all well and good, but it doesn't tell you that much about what's happening in between, right? In order to actually make use of your sprayer that's got nozzles every 2 feet or 3 feet, you got to measure it at 3 feet. Otherwise, it's irrelevant.
Right. And I'm not proposing that you need to measure it at 3 feet. All I'm saying is that if you look at the very principle of geostatistics or spatial statistics, in order for us to translate point data that we acquire from soil into surface data, meaning we're able to now estimate from information from those locations where we have not acquired a soil samples, like in this case, we need to be sampling at spatial densities close enough that we can do that prediction.
Mm-hmm.
Okay.
Gotcha.
That means we'll need to go out and take a lot of sample information. And this is part of the reason why UAVs and remote sensing and satellite imagery has been so helpful in bridging that gap, because they collect census data. So if you fly a UAV on a field, you're not leaving any square inch of field without any data collection, correct? But that happens to be a surrogate measure. You're not diagnostically collecting information. You're saying if the reflectance that we're picking up from the UAV camera sensor may be correlated to this soil property, may be correlated to soil moisture, may be related to plant stress. And by the way, we're getting better and better and better every year in improving those correlation and estimates. When you talk about we need rapid, reliable, reproducible, inexpensive ways to collect that information or the data, primary reason is that imagine you have a quarter section field, 160 acres. And if you need to go out and collect data points from 160 to 300 locations, so we're talking about at 1 acre density or half acre density, could you imagine how much it would be labor intensive, time consuming, and cost prohibitive? And this is where what we need are inexpensive sensors that can take measurements reliably reproducibly, rapidly, and without having to, break the bank. Meaning we can distribute these sensors in space so that they can provide that measure, whether it's soil moisture or soil nitrate or plant health or humidity, whatever that might be. Now that piece of information then allow us to translate those data points that are coming at high spatial densities into surfaces so that we can estimate, or some people prefer to call it predict, information about the locations where we have not taken any soil sample. When we accumulate data at that spatial densities, it'll allow us to do no guesswork. Now I can translate that into a prescription map so that I can actuate my decision at every nozzle level, either at the sprayer or at the sprinkler or whatever it is that you're trying to measure.
Thanks for tuning in, everyone. I hope you got something out of the conversation. As ever, the idea is to explore topics, items, and perspectives in the ag tech space. So if you're interested in sharing your own perspective and joining us for a conversation, feel free to get in touch with the Future Farming team at futurefarming.com. You can also reach me directly at FurRural on Twitter. That's at FERRURAL on Twitter, or via ruralphilosopher.com. Thanks again for listening.